Energy uses and policy implications of our diminishing freshwater resources. Water is our most abundant natural resource, making up 70% of the surface of the Earth. 150,000 gallons flow over Niagara Falls every second. However, fresh and accessible water makes up less than 0.007% of our total water resources.
Production of energy and electricity are straining our freshwater supply. Particularly, open-loop systems consume more fresh water but are cheaper to construct than closed-loop systems. Now let's take a look at the amount of fresh water used by our energy processes, going from worst to best in terms of freshwater use.
By far the worst is corn ethanol biomass, using over 1,000 gallons of fresh water per gallon of fuel, or MMBTU. In close second is geothermal energy, which on average uses 700 gallons per megawatt hour, but can use as much as 1,400 gallons per megawatt hour. Next is nuclear, which has the highest consumption of water for thermal cooling at roughly 800 gallons per megawatt hour. Statistically tied with nuclear is coal with carbon capture sequestration, which also uses roughly 800 gallons of water per megawatt hour. Now we come to the freshwater use winners, and we start with conventional petroleum, which uses about 100 gallons per megawatt hour of fresh water. Next, natural gas with hydraulic fracturing uses less than 50 gallons per megawatt hour. However, wind and solar energy both use roughly 0 gallons per megawatt hour and are some of the cleanest fuel sources available. Clean fuel and freshwater pollution are key factors when analyzing freshwater use. Some estimates put the amount of freshwater contamination globally at roughly 15 to 20% of total freshwater availability. While conservative estimates place algae near the top of freshwater wasters, at 350 gallons of fresh water per gallon of fuel produced, algae could be used in these contaminated waters. Now we move into past and future policy implications of our diminishing freshwater resources. Perhaps the most significant policy implication is the Clean Water Act, enacted in 1972, where the EPA implemented pollution control programs, such as setting water and wastewater standards for the energy industry.
Additionally, water in the U.S. is underpriced, which leads to much greater consumption.
Looking towards the future, there are three key economic, ecological, and geopolitical policy measures that can be implemented. First, include costs of water when considering energy uses. Second, improve the efficiency of water use and reuse. And third, focus on water conservation. While future technologies will help unlock more water supply, this will be at a much higher cost. Water is wasted because it's underpriced. Removing subsidies and letting water prices rise can provide incentives for conservation and for the investments needed to spread more efficient technologies.